We also have 24-volt system voltage. We're using 3 laser scanners, and we're making use of the platform's design that the wheels are the sides of the robots are free, and below the robot there's some space for a 3rd laser scanner, so we don't have any blind spots, which you can see in figure 4. Yeah, we mounted a new PC on the robot with an included graphics card. Sorry? Yeah, we mounted a new PC on the robot with an internal graphics card, because last year we used 2 PC systems, an NVIDIA Jetson board and an Intel NUC computer. But it's a lot of work in the competition to set 2 PCs up, and if you reboot, it costs too much time. So we decided to build a new PC. And yeah, we also did some electronics ourselves, and our main improvement, which we also brought to Australia last year, is the SCARA arm that's mounted at the front of the robot. We're using different kinematics than I think most of the teams currently in the competition, because our range and especially our effective grasping range is much higher than with traditional 5-joint arms. Yeah, because we are also always facing from top down with our gripper, and in our competition we are always grasping from tables, and this is the optimal gripper movement mechanism, I think, at least, and we designed it completely ourselves. I will show you the current state with the camera in a few seconds, but yeah. Before that, I will just talk a bit about our software design. We implemented different layers for the different software levels on the robot, because like the driver layer can easily be replaceable with simulation tasks. So during Corona, we weren't able to actually access the laboratory, and I did a lot of simulation at home. But I used most of my code like unchanged. I just replaced the driver layer, and yeah, that's the idea. And we also improved our detection, because we started with data set generation for neural networks. On the left image, you can see an original image of the gray alu profile. In the middle, that's a generated image, and on the right side, you can see a generated data image, which is already labeled, so we don't have to label all images ourselves, which would be quite time-consuming. Yeah, that's why we made a Blender script to generate our data sets, and yeah, we also implemented a new kind of robot control architecture, which consists of a task manager and a task executioner. And the manager is responsible for like all planning of the robot, and divides the incoming tasks into subtasks, like single grasp or places. Then he replans all of them, increase efficiency. And then we're going into the execution phase, and the execution phase itself is again equipped with an interpreter. So the robot decides what he has to do depending on the state it has at the moment. So he doesn't have to enter state drive, for example, if he's already at the workstation that he should be for the next task. And yeah, all of these actions that you may need or may not need will be added dynamically on runtime, depending on the robot state, as I said. Yeah, exactly. And yeah, I will give you the camera. Maybe you can show the arm, and I will prepare a navigation task. I will launch a bag file with basic transportation task 1, I think. And yeah, you can just see that our robot is able to navigate in our arena. You can also see our new arena, which we created over the last couple of months. And yeah, that's gonna be the plan for the next minutes. Hello, it's me again. So I'm carrying you now to our arm. So as you can see, it's in a build-up phase. So we're still working on it. Hopefully tomorrow we can show it to you. And if you have any specific question, I can go nearer if you want. So, and this is our gripper. Oh, it's hard now. Yeah. Yeah, I have a little special effect for you. Is the house on? We have a new grip mechanism, so we're using a parallel concept, which just moves the fingers like parallel on the table. But as we faced like some range issues with the gripper, we implemented a flipping mechanism. So at the end points, the fingers are tilted like 45 degrees or more, which opens the range for the gripper extremely, and that helps for rotating table, for example.
I would have a small question. Can you rotate the gripper around itself so that you can?
Wait, you can maybe see it.
Okay, thank you.
Okay, if you switch then to AutonOHM 2 and 3 cameras, it's not very perfect, so it's not on one screen. Maybe you will see more at AutonOHM 2. Okay, then bye from my side. So now you can see on camera 3 that the robot reached the station. I used an old backfire. To be honest, I'm not quite sure which workstations you will access, but the process is always the same. So it gets a target position, which is located in front of the robot. Then if he reaches that, he's doing an approach. So he's driving like 10 centimeters or so closer to the workstation to be able to manipulate a bit better. And yeah, then he goes into the states, into the manipulation states, for example. But as no arm is mounted on the robot right now, I disabled it. So my state machine is capable of turning interfaces on and off, or the simulation mode on and off. So you can remove parts of the system and keep the rest of the functionality and everything the same. Which also helps testing when you don't have a real robot in front of you. I mean, state machine is a huge part of our competition, and testing that requires a lot of time, also a lot of onboard time with the robot, and with that you can reduce this time and like find errors a lot earlier than if you always had to use a real robot.
This is a really cool and interesting approach. We already thought about an opportunity to provide a general interface that gives especially the visitors the opportunity to take a view into the robot. The visualization directly based on a LED setting to the ground is nice and I guess impressive.
Yeah, I'm very sorry. Right now it's only blinking blue. That's our no connection light. So normally it would turn green, or for navigation, for example, it would turn yellow and make like warning lights, so it's going around in circles below the robot. You can see that. I really hope I can show it to you tomorrow, because I think it's one of the best features for the viewers, especially if you don't quite know what the robot is doing. I mean, I'm in the work competition for almost 4 years now, and the main thing I experienced was that almost nobody knows what the robot is really doing at the moment. And with that, I hoped to provide an interface for everyone to make the robot's movements understanding better.
It's completely independent for testing in RoboCup situations. This is an important information for the new teams. You will have strong problems to have a reliable connection to your robot via WLAN interface. In this way, you are completely independent and have an additional channel to receive the current state of the system.
Ja. Ja, wollen wir noch mal kurz einen nehmen und vielleicht über den Roboter innen noch mal gehen oder so?
Eine Kamera? Okay, then we will show you the interior of the robot with camera 2. So if you like to have a look. It's not very tidy at the moment. That's due to our hard work the last days.
So what you see here is our new case. We developed it completely ourselves. It's just a completely normal PC with processor and graphics card and everything. And the power supply is located right here. It's very small. I don't know if you can see it quite. We made a case for it. And it's normally used in trucks. So it's a kind of a car power supply. So it's very cheap. It's only, I think, around 60 or 80 euros. And it can deliver up to 250 watts, which is just enough for this PC, because the Ryzen doesn't need that much, and the graphics card is powered via PCIe, which is also just enough with this power supply. But the power level of this onboard PC is very reliable in the future, because the space for the top, or like I said, in the future it's almost endless with this setup, especially compared to what I normally saw, which is used by the other teams. And the price is not even that high, because the components of the PC altogether are I think around 600 or 700 euros, which is not much more than the combination out of NVIDIA Jetson board, for example. I think this alone is 600 euros or something, and it doesn't provide that much performance. That's why we chose to use this setup. Then also go below. You can see the first laser scanner, the middle and the bottom, and also the floor light is blinking blue, as I said. But tomorrow I hope I can show you some blinking patterns.
So we are going to the home position any minute. As you can see, the light is green. That means that we are in manual operation with a PlayStation controller. So unfortunately, we have a broken wheel, maybe on a motor controller. So at the moment, we can't drive.
Okay, but probably you can illustrate some movements of your gripper system or the manipulator system. Just
Yeah. Okay, I will ask. Okay, now it's working. So I guess we start the run and then maybe we also see the arm moving.
Now it's planning. That's the planning lights. I'm not sure if you can see them. Not to none on this. Yeah. As I said yesterday, we implemented the floor lights. Now they are working. I'm not sure how good you can see them right now, but they are blinking in different color patterns. Right now it's the detection state, marked with this fading light below the robot. Unfortunately, our object IDs are not matching to the new ref box, which I just noticed, so the robot won't be able to find anything. But I think you will be able to see it driving around, and yeah.
So you need
That's the
separate section in the handbook explaining what the meaning of the different frequencies, light colors, and so on.
To be honest, we just tried them out. I just set some of the lightings. Just like for an example, the different color patterns. I did not make like an explicit list or something, but it's divided into the different operational states of the robot. So the rainbow light is if the robot replans the tasks. The yellow turning light right now is the navigation light. This is the approach light for fine navigation. That's the workstation approach light. And now it's the detection light. Yeah. But as I said, sorry.
There's an RGB camera assembled to the tool center point of the gripper.
Not the tool center point. We mounted it right above the gripper. I think you can see it. Wow, well, the camera resolution is not perfect. I really hope that the robot is also driving to another part of the arena. Kann ich ausstecken? Nee. So our camera is right in front of the gripper, and right now you could see it. Above the gripper, there's something that's our camera.
Orthogonal perspective.
Yeah, exactly.
One question about LED band. Is it controlled by the computer or microcontroller?
It's controlled with a TNZ microcontroller, which is connected to the PC via USB, just using ROS serial.
Oh, so you have a specialized topic for the LED and control it with this topic, yes?
Yeah, exactly.
Yeah, it's nice approach, I think. Looks good, really good.
Oh, that was close. Yeah. What you can see right now is also the simulated part of my state machine, which I mentioned yesterday. If something's not working, the robot just continues with simulated behavior. So you can just not use some of the parts, but yeah, it continues the rest of his actions, because as I said, state machine testing is a mandatory part. Yeah.
So you implemented manipulations, for instance, of the repositories without an action of the gripper. And at the end, the robot leaves the manipulation soon and is convinced that he has a successful grasping operation realized and is now able to place an object on another desk or manipulation.
Yeah, for example, yeah,
Okay.
exactly.
Got it. I guess recognition and all the grasping parts are not working yet. So we will see that the robot goes from one manipulation soon to another. He intends to deliver. No.
Yeah.
Why it's important to move the manipulator directly above the robot base point during the movements?
We would collide with shelves otherwise, because we're not enlarging the footprint in move base. So we're moving it out of the way, because yeah, the gripper would be like 20 centimeters in front of the robot, and this would enlarge the robot's footprint extremely, which is bad for navigation. So yeah, we're moving it aside. I'm not quite sure what he's doing now. I think he's stuck in navigation.
Any idea what's probably happened?
Just as I said before, I think this specific spot is bad for our navigation. I think it's stuck probably. I can take a look. I'm not controlling the robot, but I can take a look on my screen. To be honest, I don't know. The cost map does not show any obstacles. I don't know why he's having a hard time there. I guess that's just another task on the testing list. Yeah, that's it for this run. Yeah, I think unfortunately we can't show any manipulation.
Okay, thank you very much. Let's take a view to the referee sheet.
Great job, guys.
Thanks.
Okay, referees, please explain your decisions.
Hello. May I know why is it for tough bots? Why is it
one finalized one. Like the referee make that decision.
I think it also started in this position, just other way around. So I thought it would be fair, since it returned to its home position, that it's finalized.
And the main idea of the finalized run is if we complete the whole run with all tasks, then the team receives an additional scoring. But in this case, it's more it was more the starting point due to the fact that something went wrong. So
Okay. Fair enough.
Okay. What about the different counts? DIR has a different perspective on the run.
So BRC team, I think we add 8 series area reached because the field is really small, and I think it's fair to achieve 8 series area reached because it's like the field is small, and it's fair to count it as a different areas, so like that.
Okay. DER. We have now 64. I guess it's a typo.
Now we can leave it like that.
Okay. You just count the actual manipulation soon in different ones.
Yeah.
Okay, if I take a majority vote, I would say 8, according to the situation that 1, 2, 3 referees decided that 8 zones were reached successfully.
Yeah, they reached the 8 zones successfully, from what I see. Yeah.
Okay. Everyone is agreed? Let's take to the common results for day 1 and day 2. Wow, this is very close together. On the result sheet, you can see that RoboRectus, based on the two successful runs yesterday and today, with 1,856 points, is our winner for this very special RoboCup event. We have BRC with the second place, 1,838 points, and AutonOHM, ignoring that the team was not able to grasp anything, reached 650 points. So hopefully we'll see in the next event more complete competition runs, but for this, as I said already, special situation, it's a nice result. First place, RoboRectus, BRC second place, and AutonOHM third place. Congratulations to these teams.
Great run, guys. Thank you. Congratulations, BRC. You did well today.
Yeah. Okay. And you recognize stability, reliability are important topics here. It's not enough to have one excellent run in your laboratory. The situation in the competition is completely different. You have to spend a lot of effort to have a stable system that is able to react on specific configurations related to light, network conditions, probably different manipulation objects or arbitrary surfaces. Okay, cool. Let's follow up with a short discussion about the rule book. And I see this just as a first collection of your feedback. What do you think should be important changes in the not in the next rule book, or here we will just adapt, or it will be slightly adapt according to the situation that there should not necessary to start with a complete new development, but in the midterm, what are your ideas how we can develop, how we can reach the next level of our league? Are there already ideas?